Electromagnetic radiation can be described as waves. Now, electromagnetic radiation is often referred to as light, even though visible light is a very small segment of the electromagnetic spectrum. Sometimes people will use the word light instead of electromagnetic radiation. So let's think about waves. Here's a graphic of ocean waves. We're familiar with these types of waves. And the definition of waves is waves are able to transfer energy and are a periodic disturbance. So if we look at the disturbance of the ocean waves, the disturbance of the water is vertical. And the direction of the propagation of the waves, or the direction that the waves are traveling, is perpendicular to that disturbance. So the disturbance is vertical and the travel is horizontal. Well, the type of waves that we use to describe electromagnetic radiation are similar. The disturbance we often see in graphics are portrayed as vertical, and the direction of propagation is horizontal. So let's look at some important vocabulary words that we use to describe the physical properties of waves. First, wavelength. That is symbolized by the lowercase Greek letter lambda, and it's an actual length. It's the distance either from crest to crest or trough to trough, and it's expressed in units of meters or a multiple of meters such as kilometers, or a factor of meters such as nanometers or picometers. Another important physical property of waves is frequency, which is represented by the Greek letter nu. It looks like a V, but it's actually the Greek letter N, or nu. And frequency is the number of times that a wave passes a given point per unit of time. And our unit of time is always going to be a second. So how many waves pass by per second? The amplitude is the height of the crest, which is equal to the depth of the trough. But we are really going to focus on wavelength and frequency rather than amplitude. Now, there's a graphic here that shows two different wavelengths. The upper one is a longer wavelength than the lower one. And I'm going to use this to describe the relationship between wavelength and frequency, which is inversely proportional. The longer the wavelength, the lower the frequency. So we can see this longer wavelength, if it was traveling the same speed as the wavelength of shorter distance, in a given period of time, fewer waves are going to pass by a given point than the shorter wavelengths. Here, if I look per second, there are going to be more waves in the lower or shorter wavelength. More waves are going to pass per second because they're shorter. The longer wavelength, fewer will pass per second because they're longer. So as wavelength increases, the frequency decreases. And as wavelength decreases, frequency increases. So wavelength and frequency are inversely proportional. Now, electromagnetic radiation is called electromagnetic radiation because it has two components to it, an electric component as well as a magnetic component. We're not going to go into too much detail about these different components, but I just wanted to point out that's where the name electromagnetic radiation comes from the two different components that make it up.